Hooray, you've made it to the 4th page of the video. Either that or you just skipped to this page to get particular questions that you needed from the last one. Either way, here we go. Number 39, we're in the middle of doing our word problems. Instagram users in the US grew by about 3.5% each year since 2013. If there were 40.2 million users in 2013, how many users are there projected to be in 2020, assuming the same rate of increase? So this is, many of our word problems deal with money and investments or population. This doesn't really have to do with either. I mean, you can kind of say population because it's number of users. So the main thing to realize when choosing your formula is this one is just dealing with exponential growth. And remember, you're not going to choose the exponential growth formula with E. You're going to choose the exponential growth formula N equals N sub 0 times 1 plus R all to the T power. So other things to be conscientious of. 3.5% is going to be a rate of 0.035. Okay, additionally, 40.2 million users is 40,200,000 users. So you have to make sure that you convert those numbers correctly. When I substitute these values in, let's see, N sub 0 is our initial number, which will be 40,200,000 users, times 1 plus the rate. Again, it's growth. If I mention, so that'll be plus 0.035. If it was anything dealing with decay or a decrease or a depreciation, any of those words, you would subtract the rate. And then to the T powers time. Well, the difference in time between year 2020 and 2013 is 7 years. So T would be 7. So again, you could simplify this if you want. 1.035 to the 7th power times 40.2 million. Either way, you're going to get that there should be approximately, again, we're dealing with people, so it's important to round to the nearest whole number here. 51,145,626 projected users by the year 2020. Numbers 40 and 41 say convert each logarithm to a natural logarithm and evaluate to the nearest thousandth. So the thing to remember here is the common or the natural log or common base formula essentially says that if you have the log base 5 of 132, this would be the same thing as the natural log of 132 divided by the natural log of 5. Okay, so I want to see this intermittent step, and then you can actually type this in your calculator. Natural log of 132. Make sure you close parentheses if your calculator opens them before you click divided by natural log of 5. Round to the nearest thousandth. This is approximately 3.0339. Number 41, log base 3 of 64. Converting that to natural logs would be the natural log of 64 divided by the natural log of 3, which is approximately 3.7856. 42, Maria invests some money in a savings account. It's got a fixed annual interest rate of 5.51% compounded 2 times per year. There's the giveaway of which formula to use. You're going to use the compounding interest formula that has N, because N is going to equal 2 for 2 times a year. 5.51% interest, if you move the decimal point 2 places to the left, will be 0.0551 for R. So if I use the equation A equals P times E to the RT power, the balance, the question is how long will it take for the account to reach $10,591.59. So if I substitute in that value, 10,591.59 for A equals, oh man, it's too late, equals your principal value or your initial investment, which is $5,825. Times e to the RT, again the rate, I hope I didn't just throw you for a loop, or if I did, I apologize, and I hope you take it back with me. It is officially way late now, but I'm still trying to finish this video without having to start over, so bear with me. Let me go back to this important point I made earlier. If something is compounded 2 times per year, that means you need to be choosing the formula that has n. So A equals P times 1 plus R over n to the nt power. Okay, so now let's try this again. Our final rate is still 10,591.59. The principal investment is still 5,825 times, okay, 1 plus our rate, R over n, is going to be 0.0551, and then we said earlier n is twice a year, so that's divided by 2, all to the nt power. Well, n is 2, and then t. So our goal is to get t by itself. When you have an exponential term, you want to go ahead and simplify, and then isolate that term first before taking the log of both sides. So if I do that, and you could do a couple of different things if you want, like you could do 0.0551 divided by 2, or you can, I divided, it doesn't really matter what you do. But we can do a couple of different things at once. Let me go ahead and divide by 5,825. Get rid of that one first. When we do that, on the left side, you're then going to have 1.8183 equals. And then if I go ahead and simplify my parentheses here, I'm going to get about 1.02755, all to the 2t power. Okay, so I did a couple things. I got rid of that coefficient of 5,000, divided on both sides, and then I simplified my parentheses. Now that I've isolated my exponential term, that 2t, in order to get that down, I need to take the log or the natural log of both sides. I don't have e, so I'll just go ahead and take the log, which means that 2t is going to drop out in front, leaving us with the log of 1.8183 is equal to 2t times the log of 1.02755. And then to get t by itself, we're so close, it's being multiplied by this other stuff, particularly 2 times the log of 1.02755. And again, you could actually have typed that out and gotten that as a decimal, but I'm just going to write it like this. And then I'm going to divide that on the left side as well. 2 times the log of 1.02755. Again, you've got to be careful. If you're going to divide multiple things in one step, you've got to go ahead and group that with parentheses in your denominator so that your calculator knows that that's both in the denominator. When you do so, you should end up with t is approximately 11 years. Number 43, the atmospheric pressure varies with the altitude above the surface of the Earth. Meteorologists have determined that for an altitude up to 10 kilometers, the pressure P in millimeters of mercury, or torrs, is given by this equation. So if I give you an equation, you obviously are not going to pick one from the formula bank, where A is the altitude in kilometers. So part A says, what is the atmospheric pressure at 3.3 kilometers? So this time I'm solving for pressure. So P equals 760 times E to the negative 0.125. And then the altitude it's giving me is 3.3. So I'm going to substitute in 3.3 for A. And then I didn't say how you're going to round on this question, so I'm going to tell you now, if I haven't already said it in class at any point, but round to the nearest hundredth here. Round to the nearest hundredth. So if you type this in your calculator, again, you could simplify the exponent first and then raise e to that power, multiply it times 760, or just type it all in. Either way, you should end up with the pressure of approximately 503.11 torrs or millimeters of mercury. Part B goes backwards. It says at what altitude, so if A stands for altitude, that's now what we're solving for, will the atmospheric pressure be 450 torrs? So I'm going to substitute in 450 for P equals 760 times e to the negative 0.125 a power. So again, I've got a variable stuck inside of an exponent. In order to get it down, I eventually need to take the log of both sides, or the natural log of both sides. But before I do that, I need to isolate that exponential term. Since it's being multiplied by 760, I'm going to divide both sides by 760, giving me 0.5921 on the left side equals e to the negative 0.125 a power. Now, this is where I'm going to go ahead and take the natural log of both sides. Again, I'm choosing natural log because I have e. So then I get the natural log of 0.5921 is equal to, when I take the natural log, that exponent drops out in front. Negative 0.125. Actually, you know what? Yeah, okay, that's fine. A times the natural log of e. The natural log of e is 1. So in order to get a by itself, I just need to divide both sides by negative 0.125. So the natural log of 0.5921 divided by negative 0.125. And you should get a, an altitude of approximately 4.19 kilometers. Number 44, Ted invests this certain amount in a savings account. It's got a fixed annual interest rate, compounded continuously. That phrase lets us know that we're going to be using the equation A equals PE to the RT power. After 5 years, the balance reaches $8,207.89. What is the interest rate of that account? So let's substitute in the information that we know. We know the final balance is $8,207.89. Is equal to, we know the principal or initial investment was $5,784 times e to the RT. We don't know R, so I'm going to leave R alone. But we do know time was after 5 years. So I want to isolate my exponential term. First, divide both sides by 5,784. And in doing so, I'm going to get 1.419 is equal to e to the 5r power. And then we can go ahead and see, since I'm dealing with e, I'll take the natural log of both sides. So that I have the natural log of 1.419 equals, when I take the natural log of the part with the exponent 5r drops out front, times the natural log of e. Well, the natural log of e is 1. So then in order to isolate r, I'm just going to divide both sides by 5. So the natural log of 1.419 divided by 5 will give us the interest rate of, I think it's going to be like 0.07, maybe some other stuff. I don't remember what the other stuff is because I already rounded it. So when you convert that to a percentage, move the decimal point 2 places to the right, that would be about 7%. I would accept it in either decimal or percent format though. Last question, number 45. Kayla invests an amount in a retirement account with a fixed annual interest rate of 4.42% compounded 3 times per year. That lets us know that we need to use the formula A equals P times 1 plus R over N to the NT power, because 3 times per year means N will equal 3. What will the account balance be after 15 years? So this is straight plug and chug. I don't know my final value, so I'm going to leave that as A. The principal investment was $8,286 times 1 plus the rate over N. Again, 4.42% should be written as 0.0442 over N, the number of times it's compounded a year, which is 3, all to the NT power. Let me erase this so we have some room. Again, I know N is 3, time is 15 years. So I could simplify this a little bit if I want. Again, if you're concerned about partial credit or just making a mistake and not wanting to mess up, you can show me your intermittent steps here for more credit. So 0.0442 divided by 3, get that decimal, then add 1. So it'll be about 1.0147. All to the 3 times 15 is to the 45th power. And then if you go ahead and type this in and estimate this, that's going to be approximately $16,000 or $16,002.27. So if you manage to watch a good deal of these videos, it should have given you a great prep. Things to remember. Your test is not going to be as long as these videos are. The videos are intended to, or the study guide is intended to give you almost every possible scenario that you could potentially see on your test so that you're prepared for any and all of them. And of course, I'm going to break them up into 2 days, non-calculator and calculator, and make them a little bit shorter, so they should not take you the entire class.